Right. Comet Ison is attracting worldwide attention now because it's one of those objects which got a certain amount of mystery about it. It's come from deep space and it's now into the solar system. It's just passing Mars and it's on its way to the Sun, and is beginning to develop that characteristic tail which will make it visible to most people with a pair of binoculars. What we've been doing is using the magnetic field of Comet Ison to produce a picture of it here on the ground so that we can actually look at the detail. And we can look at, first of all, the core. As the astronomers tell us, it's got a rocky core, and this is it. Round here, this is giving us the outline of the granity, rocky core. It's about 2 or 3 miles across in this direction, and from here down to that end, it's about 8 miles long. So it is a fairly big chunk of rock. Now, outside the central core, you've got all the dust and condensed gases and everything else which goes to make up a comet. So between the rocky core and the outside of the comet, you've got the sand, the pumice dust, the carbon dioxide, the water ice, helium, hydrogen, even organics are there as well. And this is making up basically the bulk of the comet, which you can see with the blue tape going around it. Now, of course, as it gets closer and closer to the Sun, some of that evaporates, and the power of the radiation from the Sun pushes it away. So down there you'll see the tail of the comet, and in that direction is the Sun. So we know the Sun is over there, and it's evaporating a bit of the organics, the carbon dioxide, the water, and also bringing up the dust as well, and off it goes into the tail. Now, most of you, I suspect, will be aware that there's a lot of conjecture about the comet, and it has even been suggested that there are spaceships around it. Now, the methods that we use are very powerful indeed, and not only are we able to see into the comet and look at its core, but we're able to see around it as well. And that means if there are any spaceships out there, particularly those involved in mining, then using the magnetic systems that we use, we are able to identify them. And what we'll do now is look for the evidence of alien presence with or around Comet Ison. To illustrate the detail that we can obtain using magnetic fields, I can show you that we've been able to identify 6 mines on the comet. Now, the first one is this one here, where silicon is being mined. Each mine is devoted to one particular substance. So this one is dealing with silicon. This one here is dealing with aluminium. And you'll note that they're both in the core of the comet. We then have mines which are in the sort of mushy, dusty, frozen water outside of the comet. And this one is actually mining xenon and taking xenon from the comet. This one is dealing with water and is extracting water from the comet. This one is getting some of the organics. So this is accumulating organics from the matrix that surround it, and then finally this one is mining carbon dioxide. Now each mine or mine head has a crew operating it, so they're actually living beings in these mines, and we actually pick them up by using gases such as oxygen and nitrogen to demonstrate that we've got an actual habitable area in them. So this one, for example, if I'm using oxygen as a witness, I can easily demonstrate that as I close in on it, there is an area there which contains oxygen, and it also contains nitrogen as well, plus the ATP and the phosphate that we identify with living organisms. Now, the first thing that's going to be said by those who know a little bit about comets is that it's incredibly cold. In other words, the idea is that it's so cold that your helium and your hydrogen, for example, does not boil off out in space. It actually sits there until somebody wants to come along and mine it. So how do these guys actually survive in such low temperatures? Well, the first thing is that these two mines are actually in the core itself, so it's like going into a hard rock, and all you've got to do is warm it up a bit and the rock starts acting as the insulation for you. But they can also use a system which is called dynamic insulation, and if it's being supplied with gases, particularly oxygen and nitrogen, then they can let those gases permeate out through the rock and set up a dynamic insulation system. And you can actually demonstrate that they're possibly doing that. The oxygen is restricted to a small area around there, around the actual mine head itself. But if I look for the nitrogen, then as I come in looking for the nitrogen, or the nitrogen gradient, I pick it up about there, which is quite a bit further out than the oxygen contour, and that indicates that they're using the nitrogen to push the nitrogen out through the rock and set up a dynamic insulation system. Now, they may be using the same on all of these, but we haven't investigated all of them. But once you move out into the liquid, or the hydrogen, helium, everything, it doesn't act as such a good insulator as the rock, and you can pick up a temperature gradient around the mine head, and you can pick up a temperature gradient around here, which we do using colour, and so you've got quite a wide diameter there once you're in the outer layers of the comet. Quite different to if you're in the granity layer, where this area is much smaller. In other words, the heat is finding it more difficult to move away. So certainly the people who are mining here have mastered the techniques for mining at these extremely low temperatures. Now, from each mine head there has to be a method of getting whatever it is they're mining back to the ship, and these are specialized mining ships, and they are actually in communication with the mine head using what we call a standing wave system, and they move materials along standing wave systems. This is basically quantum engineering, and to understand what's going on you have to know a little bit about quantum mechanics and standing wave systems. Now, there are two standing wave systems to this mine head. And if we follow them back, we see it going through the comet itself, now along here to eventually the ship, which in this case is out here. So this indicates the actual mining ship. It's a specialized mining ship which has a hold which is now accumulating all the aluminium which this one is actually mining. The two standing wave systems, this one here is bringing in supplies to the mine head, and we've picked up nitrogen and oxygen which are going down there, and this one is the one that's bringing out the aluminium, and the aluminium goes to the ship and is stored in the ship. So this pattern is repeated with each of these ships. So this one is the xenon, so this one is accumulating xenon, and all of these others will be accumulating the particular materials that they are mining. Now, the question arises as to why the astronomers can't see all of this going on. Right, I'm standing in one part of the tail of the comet, in fact the major part of its tail, which is indicated by the blue line there and the blue line here. So from the comet, stuff evaporating from it is being pushed back by solar energy and into the tail here. So this is the main part of the tail. Then there's actual gap. There's no dust, there's no gases, anything in this part here, and we have to move over a bit further, and now I'm standing in another part of the tail which is coming here, and this part of the tail contains exactly the same materials as that part of the tail. So the question is, why is the tail broken into two sections? The answer is quite simple. There is in fact one of the mining ships situated very close to the comet itself, and the magnetic fields around it, which are very powerful, are pushing the tail apart at that point, leading to the appearance of a major tail and then a small side tail going off as well. Now as we move up into the comet, we can actually see the comet. All the blue area is where the evaporation is taking place from, and then it's being swept back in this direction. Now that was the situation yesterday, and when I originally plotted all this out, all I had was what is indicated by the blue tape. There was nothing outside the blue tape, either on that side or that side. But this morning, when I came down to do it again and get it ready for our cameraman, I found that things had changed. Now yesterday I knew that at the front there was, where the red is showing, that was an aluminium screen to protect the comet from the sun. And then coming down from that aluminium screen there was a cloaking system which is indicated by the canes here. So if I just move over to where we have the cloaking system, we have it here, so that an astronomer looking at the comet will see the comet as indicated by the cloaking system which is around it. And the cloaking system extends to here, and then it doesn't go any further because that's just a tail and no need to cloak the tail. And that was the situation yesterday. This morning
what I found was that up the front, and we'll move there in a second, there was degassing, controlled degassing through the aluminium protective layer. And we'll go up to that to see what the effect of this is on the tail. And so this is the engineered cloaking system along here, and yesterday the aluminium protective shield for the Comet started there. Today the aluminium protective shield follows the cloaking device down here, and we'll look at it in a bit more detail in a few minutes. Anyhow, going around here, the radiation from the sun is coming in, it's hitting the aluminium reflective screen. You obviously don't want basically your mine to evaporate as it goes past the sun, so you're going to protect it. But if you've got people looking at you and you don't want them to know that you're mining the comet, you've got to make it look like a comet. So at these points here, there's a red peg there, there's another one here and another one here, and these are holes in the mirror, in the aluminium mirror, and there's an aluminium pipe going back, and this enables the gas and particles to jet out through the screen, and they jet out along here, and then the sun's energy acts on them and forces it round the comet itself. So between yesterday and today, the comet has enlarged itself due to jets of gas and particles coming out the head of the comet and going around and making the comet look bigger than it was looking yesterday. And in fact, part of it will be enveloping the ships, so the ships will now be inside what appears to be the head of the comet. Now if we go back to the cloaking device here, and I'll show you something about what is happening. Now back here we have the cloaking device itself, which is made of glass, and it's got various layers of it made from molybdenum and sulfur, which have various functions in enabling it to act as a cloaking device. Now on this side, between the cloaking device and the comet itself, there's no indication of water, carbon dioxide and the other gases. This is all negative when you try to identify the materials. But on this side, you've now got the emissions from the head of the comet coming around. They're going to form the tail eventually. They're coming around, and so you get a positive response on your water, your carbon dioxide, your xenon, your sand, your pumice, and all the other things that go up to make the tail. And that goes out as far as here. So you can see that there's a very real increase in size, apparent size, of the comet to an astronomer if he's actually measuring things. Now this all sweeps back now, and it goes to form the tail. So between yesterday and today there will have been an increase in the width of the tail that astronomers are looking at, and it may even be that they can identify that the tail has sort of an outer layer, then perhaps a gap, and then another layer of material inside. So if we just summarize what we've been able to find, by using the latest methodologies that are available for astronomical research. We're able to look at the comet in detail. We can identify its core, we can identify the layers, we're able to analyze them. So we can analyze the carbon dioxide, the helium, and all the other materials which are in the comet if we want to. We can pick up the fine detail. We're not dependent on light or anything in the shorter wavelengths. We're using the long wavelengths of the magnetic spectrum, and that enables us to see even the ships which are visually cloaked. So we can pick up the mining ships and we can identify what they're doing and where they are. We can also work out what is happening. We can get a certain amount of information on the way they're mining, the techniques that they're using. They're using what is called quantum tunneling to get the materials that they want and then feed them into the standing wave systems for transportation. And to make sure that the comet looks like a comet to anybody who happens to be looking at it visually, they're able to protect it on the one hand from the intense solar radiation as it goes around the sun, and so protect their mining asset, and to release a certain amount of material to make it look like a comet, and to actually also reflect some of the incoming radiation. So we can't assume that they're doing it for the benefit of our astronomers. It may be part of their methods of protecting the comet as it gets closer and closer to the sun. Now, the mining ships are of course interesting, and we are in fact able to enlarge them. This ship here is only about a foot across, or its image is only about a foot across, but we can magnify them so that we've got a ship which is several meters across. And it's a multifaceted ship. It's got straight sides and about 10 sides with a particular bit to receive the green line or the green tunnel and to project the green tunnel. The aluminium is coming down, and the aluminium stops at a particular point, and presumably it accumulates because in the hold, which when it's magnified is over here, you've got lumps of aluminium waiting to be passed on to somebody. So the ship is accumulating a load of aluminium ingots, if you like. Now, it's got a crew. The crew has to be kept alive, so it's pressurized, it's an oxygen, nitrogen environment, and it's as well to bear in mind that in what we call the cosmic ocean, all the species are not oxygen breathing species. Some of them are what we call anaerobic species, and oxygen would be poisonous to them, and they breathe other gases, possibly, although we do not know, possibly hydrogen sulfide. Anyhow, this species is an oxygen breathing species. Now, the energy source very often is what we call cold fusion. Now, this is a method of energy generation which many of our scientists ridicule, but the species which are roaming space, so to speak, rely on it to provide a lot of their energy. And this ship has a cold fusion source here, and the cold fusion source of course operates at a very low temperature. In other words, it boils water, and so you're back to the days of steam, if you like, if you're using cold fusion. And instead of using water to take the energy away, the ones that we've looked at are normally using carbon dioxide, and so the carbon dioxide goes off and then powers generators to provide the power for the ship and all the other things which are going on. So this is the main elements of the ship. We haven't looked at it in any more detail. We've satisfied ourselves that we know who's running it, the species that are involved, and we know where the main source of energy is coming from, and we know why they're here and what they're doing.